Hey everybody, Mr. Bucko here with a couple examples from your notes from section 3.7 in solving inequalities of the form ax plus b is less than or greater than or equal to, or whatever variety of inequality symbol we want to have right here, c. So these are exactly the same notes or examples that are from your notes. I added a couple of number lines here at the end to kind of go over that a little bit more as well in case you want to go back and look again, or if you missed them all together. So first example we're going to solve for w, and with an inequality it's just like solving an equation. The only difference is that we have an inequality symbol here instead of an equal sign. So the process of solving for w is going to be exactly the same as if this was an equal sign. The only difference is that the values for w are many things as opposed to just one. But our process will be just the same, and we'll talk about that here momentarily. So we have this inequality. Negative 2 times w plus 8 is greater than or equal to 26. And if this is an equation, the first thing I'm going to do to both sides is I'm going to add negative 8 or subtract 8 because I want this plus 8 here to go away. So I add negative 8 to the left-hand side of the inequality. I add negative 8 to the right-hand side of the inequality. And when I do that, on the left-hand side, we get the negative 2w from right here. The 8's are gone, they canceled out. And on the right-hand side, we get 18 because 26 plus negative 8 is 18. Next thing we're going to do here is to get rid of this times negative 2, because we're multiplying negative 2 and w. I'm going to divide both sides by negative 2, which will cancel out the negative 2's on the left-hand side. And on the right-hand side, we will have 18 divided by negative 2. And when we do that, what we get is w on the left-hand side is less than or equal to negative 9. And you notice that this inequality symbol flipped around. And the reason it flipped around is because we divided both sides of the inequality by a negative number. We divided both sides by a negative 2. Therefore, the inequality symbol goes from a greater than to a less than. It flips around. So our values for w for this inequality are anything that's less than or equal to 9. And what that means is that we can pick any number we want that is less than 9, negative 9, plug it in here, and when we do that, this value, whatever that may be, is always going to be greater than or equal to 26, no matter what we pick, as long as that value is less than or equal to negative 9. And if we want to talk about where those values are, we can plot those on a number line. So with a number line here, we have a boundary point, and the boundary point in this case is negative 9. So I'm going to put a dot at negative 9, and I'm going to color that dot in because w can be negative 9. It is okay for negative 9 to be w because negative 9 is less than or equal to negative 9. That's perfectly fine. But w can be other things also in addition to negative 9, and that's anything that is less than negative 9. So we think of the numbers, well, what's less than negative 9? Negative 10, negative 11, negative 12. Any of those numbers we plug in here are okay for w to be. That will make this thing in the circle here true. Where are all those numbers? All those numbers are to the left of negative 9, so we would shade to the left of the dot. And these are where all our values are that are a solution or solutions to this inequality here. Another example, solve for k. Example 2, we have negative 6 is less than negative k plus 9. Again, I'm going to solve this as if it was an equation. And the first thing I'm going to do is add negative 9 or subtract 9 on both sides. And when we do that, we get negative 15 on the left-hand side because negative 6 minus 9 is negative 15. These 9's are gone, they canceled out. And we have negative k on the right-hand side. So we have negative 15 is less than negative k. We don't want to know what negative k is. We want to know what positive k is. So we're going to divide both sides by a negative 1. There's like a negative 1 out in front of this k. Negative 1 divided by negative 1 is just 1, so we'll have just the k there. And on the left-hand side, we have negative 15 divided by negative 1, which is a positive 15. But notice, we divided both sides of the inequality by a negative number. Therefore, the sign has to flip around. So it was a less than, now it's greater than, and we have our solutions. Our 15 is greater than k. So k can be anything we want in this inequality up here, as long as 15 is bigger than that number. So it can be 14, 13, negative 4, 0, all those numbers are bigger, are less than 15, or 15 is bigger than all of those numbers. So we say, well, where are those values on a number line? Well, the boundary point here is 15. 15 is kind of the critical point, as it says here in our inequality. 15 is greater than k. Well, what are some numbers 15 is greater than? We already listed a couple, or said a couple. 15 is greater than k. 15 is greater than 14. 15 is greater than 13. 15 is greater than 0. Where are all those numbers that we're thinking of? They're all to the left of 15. So anything on the green line here would be a solution to this inequality. If we plugged in any of these values in here, 11, 11.5 even, 12, 9, we can go way over to the left and you have 0, anything you want there. If you plug that in here, you will get a true statement from this, and that is solving inequalities.